Hello, my name is Karolina Drobotowicz, and I will be presenting our work with Jonathan, Laura, Joachim, and Tran on predicting customer satisfaction on airline in Vistico using decision tree and artificial neural networks. And this work was done last year for the human-centered machine learning course. Oh, sorry, there we go. So as we all probably have the feeling of, the customer satisfaction is really important factor in service design. They're in service design for the airplane service. For example, some factors that influence customer satisfaction during flights are the seat class, the delay that happened, or onboard service. And it's really important to know how much those factors are influencing the final satisfaction, because this can help provide airlines better services and therefore obtain more customers, as well as it can also help them to react in life for different situations. For example, if the plane is very delayed, they might know which factors, what to do to bring the final satisfaction to positive flow. Our goal is therefore to find the machine learning model for prediction of customer satisfaction in flights. We want to understand which factor impact the most customer satisfaction for the flights. We want to develop the model for predicting the customer satisfaction level with at least 90% accuracy. And we choose 90% accuracy because for the same data set, this was the accuracy obtained. And we want to compare how two models, the artificial neural networks and decision tree, helps in fulfilling the above goals. We were really interested in trying them both. We practice also of those both models. For us, for the data, we used the data set from the hackathon in 2020, from the airline that presented their incognito and called themselves Investico. And the hackathon was a business competition hosted by IIT Rookie in 2020. The dataset contains 22 features and over 12,000 data points. As for the label, which you can see on the right, there is different features and like different feature ranges. And for the label, the label is whether the customer was satisfied or dissatisfied, which is a binary label. However, we decided not to use all the feature points, not all the features. Sorry. We decided to skip demographics because the possible correlation between demographics and the results and the satisfaction can be results of social factors, such as how different genders or generations are being praised and treated. And we think that providing the results with demographics can therefore strengthen the stereotypes and weaken the work of the equality workers. For example, the airline could decide to continue or to start advertising their business class only to men, and therefore continue the loop of discrimination of women or elderly, for example. As for the data preparation, we first of all changed all the string values to numbers. For example, we changed the business class to number 2. We understand that those values are totally arbitrary and don't hold any meaning beyond the classifiers for each group. Therefore, we knew that we can change them to numbers. Then we needed to deal with non-existing values for around 400 data points, as we deemed this number is not big, and there was no explanation why those data why those values are missing for those data points. We decided to remove them. Next, we we performed minimax normalization because we know that it's really good practice when we deal with artificial neural networks. It helps to deal with different ranges as our data sets, as you can see here. There are very different ranges. It helps to deal with different ranges for values for every feature. And finally, we divided the data into 70% for training, 91% for validation, and 9% for testing. Now talking a bit about the models that we decided to choose. We decided to compare two of them, artificial neural network and decision trees. Firstly, about artificial neural networks. This is very powerful model. Sources tell that they can approximate every existing function to any desired degree of accuracy, even if we don't know the function we want to approximate. However, they do need a big amount of data, and it can be, and all values need to be numerical, which can be problematic when we change the categorical values into the numbers, because the transformation is totally arbitrary. But it can be problematic. It can also be simple. All values, the big challenge here is that without any additional explanatory methods is a black box model, meaning that it doesn't provide the explanation why specific output is created, what features created this. It makes basically difficult to understand the relation between prediction of the label and features. What we did with our model, we were, as for the hyperparameters, we tried different width and depth, while not changing things like epochs. And as for the decision trees, they are easy to visualize in Boolean logic and really understandable model, which is good for our goals, which was to understand the feature that is the most influential feature for the customer satisfaction. We performed the grid search on our decision tree, and we decided to stay with the depth of 15 for our decision tree because the higher depth costs overfitting, while the lower depth was not obtaining enough accuracy after the training. For the loss function, we decided to use Gini impurity for decision tree and binary cross entropy for ANN. And for comparison, we decided to use hinge loss, which is generally a good loss function for classifiers, in comparison to, for example, MSE, which can be problematic because they give the importance for the distance between the predicted label. And we here in classifier, we don't use the distances. We need to know whether prediction is good or wrong. And for the results, for the decision tree, the results of training score was around 0.97 and validation score was around 0.93. You can see the confusion matrix on the right. And for the artificial neural networks, the same, the confusion matrix on the right. Here, the training score was 0.93, and validation score was also almost 0.93. And we see that actually, which was also our surprise, that artificial neural network and decision trees had similar scores. Hinge loss was almost exactly the same for both, which means that there is same level of performance. And training and validation results were not too far apart. There was more difference for decision trees. However, if the overfitting happened, then it wasn't notorious. More accuracy would be challenging. If we would make talking about overfitting, if we would make the complex methods, that would mean that that would increase the chances for overfitting. And sorry for the noise. And therefore we also believe that talking about human subjectivity, it's probable that the accuracy cannot be larger due to the data sets, because we talk about subjective opinions of people, which might not be possible to have a deterministic way to know if the person is satisfied or not, because people with the same features might have different opinions in the end. Also, we were satisfied with the accuracy results because they were similar or even better than the one documented in Kaggle. And telling all of that, we also noticed that decision trees gives more explainability. And thanks to that, we could understand that the first node of decision tree used the flight distance, which was actually interesting because it's a feature that cannot be modified by the airlines. To conclude, we predicted customer satisfaction in flights based on given features. We achieved accuracy over 90%. Artificial neural network and decision trees had similar scores. However, decision trees provided more explainability. Therefore, decision trees is the model that we would recommend. That's all. This is the references that we used. And thank you for listening. Sorry.